Alright, welcome to section 10.3. It already looks like a great day because we only have one page of notes today. Alright, let's go ahead and go over this stuff and see what we're going to be doing today. We're looking at factoring out common factors. Now what that means is, the word factoring is what we're going to be using to describe the opposite of multiplying. Alright, last section we worked a lot with multiplying, and now we're going to go the opposite direction. So whereas last time we started with something that looked like this, and we made it, we turned it into something that looks like this. We're going to be going the other way today, and just to kind of complete that cycle and see what the whole thing really means. Okay. So the thing that I look at when, if I were just given this problem, I start with the numbers, okay, the coefficients, or just constants if there are any, and I look at is 5 a multiple, or is a factor is something that multiplies to give me 5 a multiple of something that multiplies to give me 12, and that's not the case here. But since in this one we really just have 5x times x, and in this one we have a 12 times x, all right, I have a common factor that we call it of x in both of these terms. So I'm looking for those common factors of x, and I'm going to be pulling those out in front. Okay, and then what's left over when you take that x away is 5x and 12. So that's that expression right there, and then the x out in front is multiplied by that. It's almost like dividing each one of these. So like I would divide the 5x squared and the 12x, I would divide that each piece by x. Okay, and then to say that I divided by x, well, I put that x out in front, and when I take an x away from there, we have 5x. When I take an x away from there, we have 12. Okay, it takes a little getting used to and a little practice to be really good at it, but that's what we're here for. Let's go ahead and look at the first one. So we have 15x plus 10. Okay, well, so I'm going to start with the numbers because I like numbers better than variables. So out of 15 and 10, what would be a common factor? Well, if you had to, you could write it this way. I'll be honest, I never write it this way, but 15 is just 5 times 3, and then there's an x there. And 10 is 5 times 2. Well, I have those 5s as common factors. So I'm going to take those 5s and I'm going to send them out in front. So that I have 5. What's left in this term is 3x plus 2, or sorry, 3x. And then what's left over here is a plus 2. So that would be my answer for that problem. And again, you could look at it as I'm going to divide each term by 5 if you wanted to. Whatever way works for you, that's the way that I would go with. Okay, don't overcomplicate this. Again, whatever makes sense to you, use that method. Let's go with this one. Well, it looks like they're both multiples of 3, right? Okay, well, I can do that then. 6 divided by 3, or sorry, negative 6. So whatever that common factor I think it is, I think it's 3. I'm going to put it out in front. And then 6, or negative 6 divided by 3 is negative 2. Then there's the x squared there. And then what's 3 divided by 3? Well, that's plus 1. And that's my answer. That's all you have to really write. If you wanted to check it, you could just multiply that back out and see if you get what you started with. So now, not that I always do it, or whether I always should or not, it's not a huge deal, but a lot of times if they're both negative, the number I'm going to pull out will be a negative. Okay, well, let's see, 21 and 14, those are both multiples of 7. Okay, so I'm going to write this one out like I did in the first one, just to get a better look at it, because we have a bunch of variables here too. So that would be equal to, I'm going to make the 7 negative, so negative 7 times 3, and then I have 5 n's. Okay, that's the first term. And I'm going to say that that's plus another negative 7 put those negative 7s in parentheses. And the way I get 14 is 7 times 2. So that's a times 2, and then 3 n's. Okay. So what are my common factors in this problem? Well, I have a negative 7 in each one, and then I have 3 n's are common in each term. Okay. So I have 5 n's over here, so I'll have a few left over, and I have all the n's from this one. And I'm going to pull out that negative 7. And then the 3 n's I'm just going to write as n cubed. And then what's left over? I have a 3 and 2 n's, so 3n squared. And then plus a 2 with no n's, so just plus 2. Okay. Now, you can also do this the same way you did this one. You can just think it out, divide that negative 7 out of each term, and that would work, along with the n cubed. Okay? Let's go ahead and look at the next one. So in this one, I have, looks like 3 terms. So now whatever common factor I choose has to be common to all 3 of these terms. So it has to be in that one, and that one. Okay, well, it looks like 3 would be a common factor of all these. And you can always start low, and you can always do it more than once if it's a composite number that's, all these have been prime numbers so far that we've pulled out. But if it's a composite number, you can pull it out in pieces, and we'll look at an example of those actually in the next problem. So when I look at this, I'm thinking it's 3. And then there's also at least one p in every one of these problems, or every one of these terms. So I'm going to say that it's 3p is my common factor. And so that leaves me with, when I divide 6 by 3, in fact 3p, okay, I'm going to get 2. And how many p's are left over? I'm taking 1 away, so that's p squared, minus 9 divided by 3p. 9 divided by 3 is 3. And then p squared divided by p is going to leave 1p. And then 27 divided by 3p. The p's are going to cancel, so there won't be any p's in this one. But 27 divided by 3 is 9. So that'll be my answer. Okay. Starting to make sense. That's good. So when I first look at this next problem, I see, maybe I see, well, they're all even. It might not be the best number to pull out, but since they're all even, I can pick 2. I'm going to say that it's 2 for now. Okay. And then the r's, there's not an r in every term. This one is missing one, so I can't pull an r out of all the terms. So we're going to go ahead and just take a 2 out. 48 divided by 2. It could help to have a calculator, just to double check our work, is 24. I haven't used this calculator since scientific notation. All right, so 24, and that's r to the 4th, plus 42 divided by 2 is 21, r squared, minus 15r, minus 18, just 18. But then what do you notice is you notice that they're all still multiples of one other number, and that's 3. So maybe I didn't notice that all these were multiples of 3. Maybe I don't think 48 is a multiple of 3, so I didn't try 3. But I can still do it now. So let's say we have 2, and when you pull out another number, it's being multiplied by that one. And then 24 divided by 3 is 8. So we have 8r to the 4th plus 7r squared. 21 divided by 3 is 7. 15 divided by 3 is 5. And 18 divided by 3 is 6. And then all you have to do is multiply these numbers out in front and rewrite the rest. Because there's no other common factors, because we have a lot of prime numbers over here, or a couple prime numbers and so those aren't the only factors they have are 1 in themselves, so that's all we get. Okay, so that's going to be my final answer there. Now you could have seen at the very beginning that all these are multiples of 6. And if you saw that, you could have just started by pulling a 6 out, and that's what we would call the greatest common factor. All right, we just pulled out common factors, but you want to end up with the greatest common factor out in front. All right, and I didn't pick that right off the bat, but it wasn't a big deal. Let's look at the next one. Now, because I have a couple of them that are negative in here, I can choose whether or not to pull out a negative number. In fact, I'm going to on this one, but you don't have to. It's not incorrect to do so. Because this one, if this one would have a negative, then a negative would be part of the greatest common factor. But since it doesn't, it's kind of up to you. But I like my first variable term to have to be positive if I can. It's not a big deal. So let's look at what they have in common. It looks like the whole number, you have 18, 4, and 2. Looks like that greatest common factor will be 2. And again, I'm going to make it a negative 2. And then what about variables? All right. Well, I have an h in each one, and I have at least one k in each one. But these two have j's, but the first one doesn't have j. So I'm going to say that we have an h and a k in each one. And again, if I find later on down the road that maybe I could have pulled out 2 h's, then I'd be able to tell after that. So what's negative 18 divided by negative 2? Well, that's going to be 9. And then I'm taking out an h and 1k. That's going to leave 1k left in there. All right. What's 4 divided by negative 2? It's going to be a negative 2. And I'm taking out 1h and 1k. So I'm left with 1k and 2 j's. Okay. And then negative 2 divided by negative 2, that's just going to be 1. So that's plus 1. But I'm not going to write the 1 because I'm going to have other things multiplied by it. So let's see. I'm pulling out 1h. So I'm going to be left with 2 h's. And I'm pulling out the only k. So I just have j left over. And that's my final answer. I want you to go ahead and pause the video and try these last 3. All right, hopefully you had a chance to get those done. Let's see how you did. Greatest common factor in this first one is a 4x squared. 32 divided by 4 is 8. And when you take 2 x's out, you're left with x to the third. 28 divided by 4 is 7. And I'm taking both x's out, so that's my final answer. Okay. Next one, I'm going to pull out a negative. You should be pulling out a negative in this one since they're all negative. And they're all multiples of 7. So I'm going to pull out a negative 7. And then variable-wise, every one of these has at least 4 p's in it. So I'm going to pull out p to the 4th. And let's see what we get. Negative 70 divided by negative 7 is 10. How many p's are left over? 3 of them. Negative 49 divided by negative 7 is 7. And there's going to be 1 p left over. And then negative 63 divided by 7 is positive 9. And I'm pulling out all the p's from that. So that is my final answer. Okay. And now for the last one. Whole number wise, it doesn't look like I have any number other than 1. That's a common factor in all of them. I'd have a 2 if this one was a 2, but it's not. So I'm just going to be pulling out variables, I guess. I have at least one x in every term, and I have at least one y in every term. So we're going to pull out an x times y. Okay. What's left in here? I'm getting rid of the only x in one of the y's. The 2 stays, and the y stays. Minus, pulling out one x and one y leaves just one x. And the 2 is going to stay in that one. But that's it. And that's my final answer. Hopefully you got some of that. It's a pretty good skill to have. And as you keep doing it more, the more practice you get, the better you'll get at it. So good luck with the practice application and mastery challenge. And come on back for the next section. In our quest for finding the top 5, or the number 1 funny cat clip, we have number 5, tread kneading, number 4, cat acrobatics, and now number 3, simply titled, What is That? Okay, good luck figuring out what's going on here. It's pretty hilarious.